Before we begin, for anyone that maybe is new to data science for everyone, I'll give a little background on our work. We are a national initiative. We focus on bringing data science and data literacy into every K-12 classroom. To do that, we focus our work primarily on the four pillars that you can see on the screen. We work on raising awareness, gathering and catalyzing classroom resources, building community, and working on policy as it relates to getting data science education into classrooms. I'd also like to briefly remind everyone about our community standards. While we welcome coalition members of all different backgrounds and levels of experience with data science education, we like to create room for healthy and engaging debate and discussion. So we've established a code of conduct that we can drop in the chat that just creates an environment of respect and inclusion. Um, Also, just for Zoom etiquette, which I'm sure post-COVID we all know, if you wouldn't mind just keeping yourself muted while our presenters are speaking so that we don't have any distracting background noises, that would be amazing. And I also want everyone to know that we welcome and greatly appreciate any questions that might come up as any of our presenters are talking. If you wouldn't mind just dropping them in the chat, myself, my coworkers Shay and Matangi will be monitoring those, and we will save those for a little Q&A at the end. Um, I think that's it. I guess the only other thing that I will say is that all of our presenters are going to be showing some of their work today. And so if for some reason there's an issue and you can't see someone's screen, go ahead and just flag that in the chat so we can get any technical issues ironed out and you can get the most from our webinar. So with that being said, let's dive into it. I'm really delighted to see so many people joining. I think it's going to be a really fascinating exploration about how young researchers are using data science to examine language perceptions and implicit bias that might be there. I think tonight's webinar is going to really highlight a quite exceptional example of student-led research and how that can contribute meaningful insights to established fields of study. Anna's going to focus on a remarkable project that she did that investigated the difference in language perceptions between Latin American Spanish and other Romance languages. Um, she had a wonderful guidance and the ability to do this because of her dedicated teacher, who will also be talking about how this is not impossible and that all educators can do this for their students. So ideally, I hope that regardless of your background or role, you're inspired by both the research methodology as well as the mentorship and the relationship that supported that work and can use that in your own classrooms. So I'm going to introduce our speakers today. To begin our program tonight, we are going to start with Aaron Reedy. He's the founder of DataClassroom. Aaron's platform has revolutionized how students can engage with data and do data analysis. It really helps them make sophisticated research tools accessible to younger scientists. His work has really been instrumental in supporting projects, much like the one that you're going to see today, and really allowing and breaking down some of the barriers that students might face when they're trying to conduct rigorous quantitative research. We really commend his commitment to democratizing data science education. And as one of our content partners, DataClassroom is something that we really stand behind as an organization. And we think that it's really helping advance data science education in the classrooms. After he speaks, we're going to pass it off to Michele. She is our teacher, an exemplary educator who demonstrates kind of the transformative power of mentorship in terms of scientific education and data exploration. She teaches at Sleepy Hollow High School, where she's developed an innovative approach to integrating authentic research experiences into her curriculum. She's very dedicated to fostering student-led inquiry beyond just traditional classroom instruction, which I think is what brings that sense of engagement in her students. And then as our student highlight tonight, as her teacher, Anna's teacher, she provided like the crucial guidance and help that Anna might have needed while she was diving down this pretty deep and quantitative investigative approach. And so we will end our talk this evening with Anna. Her project is called Evaluating Differences in Language Perceptions Between Latin American Spanish and Other Romance Languages. It was published. I'm sure she's going to talk about that. We will drop a link in the chat once her part comes up. But it really represents quite an exceptional contribution to sociolinguistic research. As a high school student, she designed and conducted a very sophisticated study examining how adolescents perceive different Romance languages with a particular focus on Latin American Spanish dialects. Her research addresses important gaps in sociolinguistic literature, which has traditionally focused on European Spanish varieties and adult participants. So this is quite a unique take on this branch of science. Her project demonstrates remarkable methodology and rigor. She collected data from a lot of participants. She designed thoughtful assessments, applied appropriate statistical analyses, and I think came up with overall quite an impressive project that I'm going to quit talking about so I don't steal all of her thunder. So with that being said, I am going to quit talking because I have talked enough, and I'm going to pass it over to Erin, who's going to show you the platform that kind of got this going.
Thank you for the incredibly kind introduction, Hannah. I am going to switch over my screen and share with you all. And just give me a thumbs up if the screen share came back with the slide. Or hold on, we are on pause and let me resume. Apologies, I think my computer is just lagging a little bit. Bear with me here. I'm going to share again and just try this. There we go. You all are now seeing the slide again, and we're back. So thank you again for the incredibly kind introduction. That was really lovely. Um, I just want to tell you a little bit about what DataClassroom is, and then we'll pretty quickly move on to Michele and Anna, who are really going to be the focus of tonight. Um, I just want to say that my background was as a high school science teacher, so I have been in Michele's shoes, or at least something similar to them before. I taught in the Chicago Public Schools for 7 years, and just many of the ideas for DataClassroom came out of that experience in working with kids. And if I'm being quite honest, many experiences where graphing and analysis at the end of a lab would kind of go off the rails, and we would lose some of the enthusiasm that we had for a good lab activity in getting bogged down in the details of making a graph and asking deep analytical questions, and oftentimes those questions didn't end up being as deep as I had hoped they would be. That led me to start working on DataClassroom as a graduate student at the University of Virginia. And the DataClassroom platform is a tool for graphing. That's one of the core functions of it. It also provides a guided approach to statistical analysis. And I think Anna will kind of showcase how she used that guided approach to produce some of her research. And Michele will also talk about how she uses that approach to reinforce her teaching. In addition to graphing and stats, we also have a library of real-world data sets that are on the platform. Some of them are pulled directly from the published research literature. Some of them are pulled from classrooms and are examples of kind of classic lab activities. So there's quite a bit of mix in there, but it gives students something to practice with, even if they don't have their own data, or maybe even how I prefer it, it's something to practice with first before they inevitably move on to working with their own data, which I think is such an important part of learning data science skills. I want to drop away from the screen share in just a second to actually share a different screen and show you some of DataClassroom. If anyone's interested in a free trial of all features on DataClassroom, you can scan that QR code, and that will give a 60-day trial of a teacher account. Even if you just go to the website, though, and create a brand new account, you ordinarily will get a 30-day version of that. There's some things that are always free in DataClassroom, but if you scan that QR code, you'll have access to everything for a little bit. So let me really quickly, and this might be the easiest way to do this, is to just jump over here. And are you all seeing my DataClassroom dashboard now?
Not yet.
Did that come over? Not yet. Okay.
Now we can.
Now you can. Okay. It's just moving slow. So it moves in real time on this end, but it's crawling through the magic of the internet there. Um, so this is the Data Classroom dashboard. I'm going to really quickly open up the resource library, and I'm just going to pull a data set from here and just kind of show how a student would go about asking some questions with that data set. We have data sets on a pretty wide variety of topics. Some of them are biology, environmental science, some of them are sports, some of them are economics, some are even kind of pop culture type things. But one of my favorite data sets to demonstrate with is this one called Cicada Sex Education. And it's all about looking at sex differences between male and female cicadas, differences in body size, and looking at those differences across different populations in North America. Looking at these biological sex differences is also the topic that I studied as a researcher. I worked with lizards, not cicadas, but this is a general line of inquiry that's near and dear to my academic heart. But within Data Classroom, when a student has a data set, and keep in mind this would be the same if this was their own data. So Anna brought her own data into the platform, and she'll kind of show you the end results of what she did. But within Data Classroom, we have the philosophy that when a student starts asking a question of data, the place to start is with graphing. This was the kind of training that I received in my PhD, reinforced that. My PhD advisor always said, if you have a question and you're going to ask it with data, let me see a picture of the data first. And so what you're looking at here is just a dot plot with all of my observations of head width. And so there's about, I think, roughly 350 observations in this data set. And we can see the head width there. And if we have a chief question of, are males and females different sizes, we can add a second variable. And I'm going to add this variable called sex on there. And you'll see that pile of data points in the middle get split into two. And, just with a very, very basic graph like this, we can already start asking questions of this data set. And we can say, it looks like there's a lot of overlap between male and female head width. And it looks like maybe, typically females are a little bit larger than males are on average. And we can see that the very biggest measurements are all female measurements, and the very smallest measurements are male measurements. We could kind of introduce some, what I like to call pre-statistical thinking to this, and we could start comparing these with in a little bit more quantitative way. And so I'm going to just go ahead and add some descriptive stats here. And now we're comparing these two. We're looking at box plots where the line in the middle of the boxes is showing the median, and the box itself is showing the middle 50% of the data, and the whiskers are showing the range from the highest to lowest value. And so now, now we can quantify this, and we can say, not only does it look like females are bigger than males on average, we can say the median female is 8.37 millimeters and the median male is 7.9. So now we've, introduced some statistical thinking to this. Or we could take this one step further, and Anna definitely did this with her project. We could apply statistics to this. And as an experienced mentor, I could look at a student project like this one, and I could say, well, this looks like pretty classic t-test data to me. What, you want to know if the mean is different between the male and female groups in light of all that variation that we see. And within Data Classroom, when I launch this graph-driven hypothesis test, it's going to take a look at the data, and it's going to say, yeah, I can recognize that does look like t-test data. And when a student goes and calculates that, they'll get a little pop-up that reinforces why the t-test is an appropriate choice in this situation. And then they can go ahead and, get their statistical output that they would report in their paper or in their science fair poster. And they can dive in and get a little bit of an explanation of these parameters that come out. So this p-value or probability value, we help students understand, what this would typically mean. And so in this case, less than 0.01 means extremely strong confidence that these groups are different. And I could, dive in and get a little bit more explanation if I want that there. And that's what we try to do with our tools is put those helps at the fingertips of young researchers at the point in their research, when they would want to do those things. And also, if they want to dive in and ask an auxiliary question, like maybe we wanted to ask the same question and see, does this difference in between males and females, does this persist across the three major species groups in North America? Well, I could explore that visually. I could, add those on where now I've colored the different species groups, different colors, and I could group them out completely into the subgroups that are formed by the combination of sex and species group. And again, if we go on to statistics here, Data Classroom, would tell you this is a two-way ANOVA because now we're testing to see if there's an effect of sex, and we're seeing if there's an effect of species group, and we're seeing if the effect of species group depends on the sex or vice versa. So these are the kind of tools that we've set out to build, and the kind of tools that I'm really glad have ended up in the hands of teachers like Michele and students like Anna. So with that, I will stop the screen share and I will pass it over to Michele, who I've had the pleasure of communicating with over email for the last few years as a Data Classroom customer, and it's just really exciting to both be on the same webinar tonight.
Thanks, Aaron. That was really nice. Yes, and Aaron is kind of like my mentor as I'm learning as I'm learning statistics alongside my students. So hi everyone, my name is Michele Zielinski. I'm excited to explain to you or show you how I use Data Classroom in my science research classroom. So I thought I'd start a little bit. Can you see what I'm seeing? Yeah. Okay. I thought I'd tell you a little bit about my background first. So I studied engineering in school and I have 10 years of experience as a structural engineer. And then I had three children and I became very interested in education. So I went back to school and became a science research teacher. And I've been a science research teacher for 12 years and it's been an enjoyable experience. I've loved it the whole way through. So I teach at Sleepy Hollow High School, which is a mid-sized school, about 1,000 students. We are a Title I school with open enrollment. So that means that we have very few restrictions for students taking upper level classes like science research. So I teach science research. I don't teach statistics, and I'm using statistics quite a bit. It's an elective class, so they take science research alongside another science class. It's a 3-year class beginning in 10th grade. It's a college level class. They can earn up to 12 credits in college through State University SUNY Albany. And it's an independent science research class, which you'll understand in a second. So a lot of the content that students have to understand is self-taught or taught by mentors. So you might be wondering, what am I teaching then? I'll explain in a second. And it's really the first time that students are being asked, what do they want to study? What does a student in 10th grade want to study? And so they have a lot of options. And so I have students that are studying engineering or animal science or behavior projects or medicine and everything in between. So what exactly do we teach in science research? So this is kind of a very simple version of what it might look like, what it looks like in our classroom. In 10th grade, in Q1, we introduce students to journal articles. So they're reading about research that's happening in the field that they're interested in. Every student is reading a different article. In Q2, we start to explore, well, how do you run an experiment in that field? And we start to focus on methods, experimental design. And as soon as you start to talk about experimental design and data, you have to talk about statistics. So statistics comes into play in Q2. And then we have students write a research plan, which is basically pitching a project and how they're going to approach that project. And then in Q4, they turn that into a poster with a presentation and they go to a competition. So that's what 10th grade looks like. And there are many ways through this 3-year program, but I'm going to explain to you how Anna went through it and how other students might go through it. So Anna's research plan was in great shape. She got her IRB. She was ready to go. So over the summer between 10th and 11th grade, you can collect data. Once you come to us with data in 11th grade, we the teachers at Sleepy Hollow, as well as the Anna's mentor or any mentor, would help students analyze data and write a research paper. And mentors are involved to different degrees. So a lot of times it falls on the teacher to have to figure out the statistics with the student. So that research paper that they write then becomes their entry ticket to a very large engineering fair called the Westchester Engineering Fair that we participate in. And it's the largest high school science fair in the United States. We have 830 students, and they're all really impressive projects. So it's kind of a big deal getting to that stage already in junior year. And then in quarter four, we have them write a new research plan to do a new project in 12th grade. And so again, collect data over the summer, and 12th grade looks very similar to 11th grade. So where do statistics come into play? Well, all over here, this is where statistics comes into play. Beginning in the first quarter of 10th grade, students start reading journal articles and they start noticing, what's a chi-square? What's a p-value? And the more you try to explain it, the more you start to introduce stuff that they don't know, because now you start talking about null hypotheses. And so these are all some of the challenges that we face. In quarter two, we start to look at methods and statistics. And again, we have to introduce statistics. And so we're talking about all kinds of statistics that pertain to different kinds of data. In quarter three, when they write their research plan, they have to include a data analysis section. The data analysis section is very specific. What data are you analyzing and how are you going to analyze it? And then in 11th and 12th grade, it becomes even more interesting, because while we're teaching more in 10th grade and their ideas are developing, in 11th and 12th grade, when they have their own data, now it becomes the students become much more responsible for their statistics, and the care and the effort they put into it is really tremendous. So here are some of the challenges that I experience teaching statistics in my class. So students don't have a background in statistics in 10th grade, but they introduce to things like p-value. And the more you try to explain it, the more you dig your hole. So you have to explain a certain amount. So null hypothesis, parametric, non-parametric, all of these things come up. They do have some sense of what a best fit line is. And so R squared, they kind of get that idea. So that's helpful. In Sleepy Hollow, we don't have an AP statistics class, but students see value in statistics. And so our strongest math students in 11th and 12th grade would take an AP calculus. And I know Anna's going to talk a little bit more about that, so I'm going to let her talk about that. And then because of the variety of interests that my students have, students need all kinds of different statistics. So it's very hard as a teacher with very limited time to decide which one do I choose to teach. So I have very limited time in science research. It's 45 minutes every other day. So about 20 classes in that quarter two is what I'm looking to teach experimental design and some knowledge of statistics. So you can understand why that might be so challenging. I would describe my teaching style as a scaffolded teaching style. I'm very honest with students. I tell them statistics is a really big field and you can take lots of college classes in statistics. I am not going to make you an expert in statistics, but I am going to give you some of the vocabulary and some of the concepts so that you can build on what we learn in this classroom. I start with a t-test and I have every student in my class do examples. Aaron's examples on DataClassroom with the data included. We work through those examples. And that's how I introduce the idea of what a hypothesis is, what is a null hypothesis. We talk about normality, and I have something called a research question formula, which I think complements Aaron's style and DataClassroom style of explaining statistics. And so what I want the students to really understand is that different statistics apply to different kinds of data. And a lot of times we have to reference journal articles, and I ask students, what kind of data are they collecting, and what statistics are you noticing that they're writing about? And that leads us to what we try to explore next. So this is an activity that I might do with my students. I'll show them a data set, a simple data set like this, and I'll ask them, what research questions can you ask? Very similar to how Aaron presented it earlier. And so they'll start to notice, oh, I have gender. I know something about the gender of my participants. I know whether they were a musician or not. I know something about a study technique, and I know what their math score is. And they'll come up with a variety of research questions, but some of them will come up with something like this. Is there a difference in math score between musicians and non-musicians? And so we build on this a little bit further, and what I stress to them is look at those variables that you're introducing in that question. You have a numerical a variable, math score, and you have categorical variables. There are two of them, musician and non-musician. And so eventually I teach them to generalize this. So this kind of a question lends itself to a t-test. And you can generalize it like this. Is there a difference in numerical dependent variable between two categorical variables? And so if you can replace any of those terms, numerical dependent variable, with another, and the same thing with the categorical variables, you're likely to need a t-test. So some of my students did something like, is there a difference in working memory between dancers and non-dancers? That's the same thing. So that's how they take this example and they build off of it by generalizing it. Furthermore, that's complemented by DataClassroom's graphing features, because again, you're seeing now, okay, so what would this data look like? And so they see something that looks relatively familiar to them. They see this dot plot, math scores on the y-axis, musicians and non-musicians. And there's a feeling, I think, with students that it's easy, I get it. But the more you think about this graph, the more interesting it gets, because this is, I think, the first time, Anna, you can comment on this, whether you feel this way, but I think this is the first time students are starting to think about error bars and what are those bars. And the other thing I like about DataClassroom is the data points here. I don't know if I have a pointer here, but the data points are representing each participant's contribution to this study. And then the summary of that data to the left is this one average with the error bars. And they start to understand something about the sample size, because there was a lot of data behind that average. In the past, I think students typically just do bar graphs, and a bar graph doesn't really give you that intuitive feeling of how much data was behind that bar graph. And again, I think Erin showed us a very similar screenshot earlier. And so this is something that, again, is reinforcing the idea that a t-test applies because you have categorical variables on the x-axis and you have a numerical variable on the y-axis. So I like to complement that with that research kind of question formula. Again, so to say this again, these data points are really giving students a lot of information for the amount of data that lies behind a simple average, which is just a simple summary of all of that data. And they start to ask questions about confidence intervals. So they really get a sense for, it's not just the average and comparing the averages, it's also about certainty. How certain are you about that data? And these are good questions for critical thinking and to get them thinking about research in general. And so after you run that hypothesis test, they're able to get that magic p-value, and DataClassroom helps them interpret that p-value. It's not so black and white. There's some gray areas there, and it really helps them to read what DataClassroom's explanation of a p-value is, and then and then develop their own interpretation of that value. So is this a successful teaching method? So here's what I've heard my students say. So they realize that they don't know everything about statistics. Well, good, because statistics is a big field, and it's a long journey, and they should be prepared for that. But they are confident in their abilities, that they can do something. They feel confident that they can do a t-test. They're also able to communicate with their mentors and other scientists. So they know what they're talking, when they talk to professionals in the field, which is a big part of this program, they're able to understand what these scientists are talking about. They're also able to consider other explanations of a t-test. So recently I had a student sit in on a college level class in which they were explaining what a t-test was. And I guess they explained it differently, or added more information. And he came back and he said he was able to grasp what they were saying because of the foundation he had. He had some idea of what a t-test is, and this just built on it. So that's really helpful to learn. They also really learn best when they interact with their own data. And we move away from this academic exercise to an authentic research experience. And I mean, I can liken this to some experiences, some experiences in engineering. I mean, sometimes you just have to figure it out. And that's what students are doing. They have to really dive deep and figure out how to analyze this data. And the other thing they develop is, wow, data analysis takes a long time, which is really interesting. But I think that most students have told me that they thought it was, I just do a graph and I I make a graph and I explain it, and it's that simple. But what happens is the more they develop, the more they dig into their data, the more they see in their data. And so they start to think about different questions. And what if I do this? And what if I do that? And what if I look at the data this way? And that's where a lot of critical analysis comes in. And that's a fantastic experience for them. Data Classroom gives them that ability. It puts them in control, and they're able to do that. So in conclusion, I will just say that Data Classroom helps make statistics attainable for students. It helps address the wide variety of statistics that my students need for their projects. It allows students to visualize data with error bars, so it's a very professional approach to viewing data, and it gives students the authority of their own data and the ability to ask those what-if questions. So I'm really excited to introduce Anna. Anna has been using Data Classroom for 2 years. As a junior, she got her research paper published, which is the one that she's going to present today, but she's got another one coming down the road because she'll be presenting on Saturday at WASF for her 12th grade project. So I'm really excited to introduce Anna, and I'll stop sharing my screen now. It was great to meet you all, and thanks for listening. I really appreciate it. And off you go, Anna.
Hi, thank you so much. Thank you, Ms. Crowell, for your introduction, and thank you so much, Ms. Zielinski and Mr. Reedy, for your introductions. My name is Anna Poret. Sorry, I'm going to the next slide. As Ms. Zielinski said, I'm a senior at Sleepy Hollow High School. This is my 3rd year in science research, and I'm working on my 2nd study now. So the one I'll be presenting tonight was completed in junior year. It's titled Evaluating Differences in Language Perceptions Between Latin American Spanish and Other Romance Languages. And then this year I've moved on to studying more specifically an educational bias within sociolinguistics. So just to introduce kind of how the math and data science curriculum works in my high school, at least, I wanted to show the courses I've taken. So here, sorry, I'm trying to move around so that I can see the whole slide. Um, so I've taken Algebra 1 honors, in which we learn a little bit about box and whisker charts. We never cover p-values. We learn a little bit about graphing, but that's as far as it goes. As for statistics, then geometry, which has no focus on statistics. And then in my junior year, in order to take AP Calculus, as it's generally advised to take a college level math course when applying to colleges, you have to take half a year of pre-calculus honors at the same time as Algebra 2. Algebra 2, again, focuses very little on statistics and was taken after I was already in science research for a year. And then this year I'm taking AP Calculus AB. So for my research, to introduce you to this whole world of sociolinguistics, the main statistic I focused on was that in 2021, 23% of Latino Spanish speakers reported facing criticism for speaking Spanish in public spaces. Now, for my background, I think it's important you understand I was a part of a K through 5 dual language program. So starting in kindergarten, half of my classes were in Spanish and half were in English. So I have had a lot of exposure to language, and I've kind of grown up very fascinated with this because of my background in language. And when looking at languages, I think often English speakers or people who don't speak Spanish in general don't understand quite the diversity of these dialects, but you can speak a entirely different variation of the language, both in grammar and also just in accent and vocabulary. So for my review of literature, I focused Calzano and Carter, who I mentioned here, my mentors, and I looked at their studies, which was focused in on Miami, which I thought was really interesting because they chose to do research in diverse, both ethnically and linguistically diverse cities because of what that says about their data. So they studied Miami college students and their perceptions of 3 different dialects of Spanish: Peninsular, which is the word for dialects in Spain, Colombian, and Cuban dialects, and they did it in terms of warmth and competence traits. Competence traits I would go on to focus on more because it referred to things like intelligence, self-confidence, and trustworthiness, things that I really saw to apply both in hiring in the workplace and also in education if you're a student and how your teachers perceive you. Miamians rated the Cuban and Colombian speakers as significantly less competent than the Peninsular speaker. And I thought this was so interesting because 70% of Miami-Dade County, where they did the research, is Hispanic. And of that 70%, 43% specifically were Cuban. So I thought it was so interesting that generally, when looking at implicit biases, you see an affinity bias. You see someone biased towards someone or something that they perceive as most similar to themselves. And here, there was a population that was predominantly Hispanic, and within that population, predominantly Cuban, having a negative response to a Cuban Spanish speaker. Looking in Carter et al. 2018, there was a similar response, as you can see. I'm not sure if you can see my cursor, but there was a more negative perception of the Cuban and Colombian speakers, except they focused on things like that predicted social outcomes. So jobs, employment, and income. So this graph is average annual income in tens of thousands of dollars. And people, despite, again, it was done in Miami, there was a predominantly Hispanic, predominantly Cuban background of students, they still had this negative perception of the Cuban speakers when compared to a speaker from Spain. And this shows this Eurocentric linguistic bias where people favor the dialect that is most European. And this exists in other languages. I chose to focus in Spanish because of how prevalent it is within the US and within my own education. And then looking at Kogan et al. 2021, this graph shows different language families. And looking into linguistics, you'll find that Romance languages are very positively perceived, this graph being of beauty. But in general, in further into the study, you see that the perceptions of French, Italian, Spanish are generally roughly similar, and they all place similarly when looking at both beauty and competence. So I wanted to look at this same phenomenon, except instead of using a dialect from Spain, I wanted to use a dialect from Latin America because it's a more representative version of research of Romance languages within the US. So the gap was that most of this linguistic research, when focusing on Romance languages and looking at things from a linguistic perspective and less of a sociological perspective, used European dialects, so Spanish from Spain rather than Latin American dialects. And most Romance language research does not represent the majority of Spanish speakers, which I thought was really interesting because I believe if you want to research the Romance languages, you should be best representing its speakers. Furthermore, participants were generally adults, and as a high school researcher, I chose to focus on adolescents because I thought they would have a lot of insights. I know personally I have a lot of thoughts and opinions and interests related to language, and I wanted to know what my classmates would think. So, the problem statement. While many studies center around Spanish language perceptions, there's a lack of research comparing Latin American Spanish dialects to other Romance languages. So, my goal was to understand these perceptions of the Romance languages, specifically with the Latin American Spanish speaker, through both phonesthetic qualities, the perception of beauty in languages, and also implicit social perceptions. So things like perceptions of someone's job and income, and things that have a more that predict social outcomes. My hypothesis was that ratings of the phonesthetic qualities and implicit social perceptions of the Latin American Spanish would be lower in terms of competence and occupational prestige. So for my methods, I created voice recordings, which were of three teachers. So I recorded them all speaking the same phrase. I designed a rating task from the University of Vienna Phonestetics group, and I also, with permission, used the implicit bias survey from Calisano et al. 2019. And my participants completed both of these surveys, listening to the recordings, and then for the phonestetics rating, answering things like questions about how beautiful or orderly or how structured a language is, averaging their scores. And then the implicit bias survey, it was again a 7-point Likert scale, but it was about the likeliness of the speaker to have certain traits, and also to have certain jobs and certain incomes. So jobs that are associated with higher pay and requiring higher education versus jobs that don't require as much experience in a certain field and don't pay as well. And the language recordings were one of a Puerto Rican Spanish speaker, a French speaker, and an Italian speaker. They were all female, bilingual, and they were reading the same passage in their specific language. And then for the demographic survey, I used the standard age, gender, and ethnicity, but I also included the places that participants have lived in and their familiarity with languages, their their acquisition order. So when looking at languages people speak, the order in which they acquired them is really important. And then also their recognition of the languages in the study, how familiar they were, and their linguistic and personal background. So for my results, I think it's important to acknowledge how really just how helpful the data classroom was in understanding statistics and understanding these results because Ms. Zielinski does an incredible job of teaching us everything that we don't learn through our math curriculum. Uh, but she does a fantastic job of helping us understand, for example, the Kruskal-Wallis test I used for the likeliness questions from the implicit social perceptions questionnaire, and she teaches us this is categorical, but oh, if you run a normality test, it's not evenly distributed, so we need a Kruskal-Wallis test. And Ms. Zielinski did a fantastic job of explaining to us why you need certain tests, why the distribution of your data points is important. But when you look, I don't have an image of it here, but when you look on Data Classroom, there's also features. Like it says, do you want to include non-parametric tests? And I clicked on that, and it teaches you how to interpret it. And that was really crucial to my understanding of of my findings, because when looking at the implicit social perceptions, I get a p-value and I see, oh, it's less than 0.05. And through my education, through the science research program and data classroom, I understand, oh, that's what the 95% confidence interval, and this is what it tells me. I also used a chi-square test of independence for the language guessing accuracy because that was based on the frequency at which participants guessed accurately. And then I also used an ANOVA for the questions that were from the University of Vienna Phonestetics group. So these were all of my findings that included statistically significant p-values, but I wanted to focus on three specific ones that I thought had the most important implications socially. So these three graphs were all statistically significant findings. As a reminder, competence traits refer to things like intelligence, self-confidence, and trustworthiness, but there's also profession-based perception of competence. So that's someone's association with the speaker as of related to a high-paying job with high education requirements. So these three questions, comparing likelihood of working as a salesperson, working behind the counter, and guest income, all of these showed a more negative perception of the Puerto Rican Spanish speaker. So one, they perceived the Spanish speaker as significantly more likely to work as a salesperson or behind the counter, and were perceived as associated with the lowest income. And among the questions relating to professions, there were also questions about working as an executive and working as an attorney, in which the French and Italian speakers were perceived as significantly more likely to have those jobs. So in general, sorry, I'm going to go back. A negative, there was a more negative perception of the Puerto Rican Spanish speaker. And I thought that this was particularly interesting because, as I mentioned, looking at the studies done in Miami, despite the background of the participants, there was still this negative response to a dialect that they would be more familiar with. So of my 101 participants are all high school students. About 70% spoke Spanish, and about 50% identified specifically with the Latin American country, and about 20% identifying specifically with a Caribbean country. And when looking at grouping of dialects, Caribbean dialects have many similarities. So a familiarity with a Puerto Rican dialect that my speaker had is similar to a familiarity with Dominican and Cuban dialects that many of my participants shared. So to conclude, when looking at the Puerto Rican speaker, she was perceived as most likely to work behind the counter at a local store, and this is all based on voice recordings, likely to have the lowest income, and most likely to work as a salesperson at a retail store, whereas the French speaker was perceived as least likely to work behind the counter at a local store, likely to have the highest income, and with the Italian speaker, least likely to be a salesperson at a retail store. When looking at the Italian speaker, they were less likely to work behind the counter when compared to the Spanish speaker, and with the French speaker, least likely to work as a salesperson at a retail store. And this was based in they also had a higher mean and median guest income compared to the Spanish speaker. So the results supported my hypothesis for both phonesthetics and implicit bias, these, as there was a more generally negative perception in terms of the competence of the Latin American Spanish speaker when compared to the French Italian speaker. And this is a part of this opposite of affinity bias, despite the prevalence of Spanish in the community of my participants, despite the fluency of this community and their general familiarity, there's still a negative perception. Um, and that the implicit social perceptions of the Latin American Spanish speaker were more negative than the perceptions of both the French and Italian speakers. And this was in connection to occupational prestige, this phrase referring to respect and status associated with different jobs and things that are hugely important when if you're looking to get a job, if you're in school, it has many real world applications. And I thought this was so interesting because generally, when looking at biases, you see, when studying something like this, perceptions of language, you see an affinity bias. In research, it's not surprising to see a speaker from France prefer the sound of Parisian French to Canadian French, something like that. But in both my research and the studies that I had focused on, I saw the opposite. And this really fascinated me. So here are my references, and I just wanted to show this is what my poster at the end looked like. This is what I went to WSF with last year. I used the Kruskal-Wallis test, chi-square test of independence, and an ANOVA. This was all from DataClassroom, which really taught me so much about statistics, and I think with Ms. Zielinski's guidance in science research and her approach to teaching statistics is really the only thing that bridges high school students who would otherwise be unfamiliar with even what a journal article is and unfamiliar with many important much of an important baseline statistical knowledge to I mean it's the reason I got published. It brings you so far, and it also has made it so much easier to do things like get a mentor. And it was such a different approach being able to talk to a scientist whose work I admire and who I respect so much, and being able to say that I understand that it was a two categorical variable, so I use this test, and DataClassroom is just such an incredibly valuable tool for those reasons. And I also wanted to show this is my senior year presentation, but as Ms. Lensky mentioned, I'll be going to WSF on Saturday. However, on this, I focused on elite bilingualism, Eurocentric linguistic views, intercultural biases, sociocultural perceptions, and then blind spots in bias research. Thank you.
Oh, that was amazing. Thank you so much. I'll remind everyone that you are free to drop any questions you have in the chat. I've got a few that I'm going to get us started off with. And then I will go ahead and look and see what else that you pop up with. The first one that I got actually is for you, Michelle. Primarily kind of a question about something you said when you mentioned learning statistics alongside your students. I feel like there is a big barrier with teachers that feel very nervous about data science education. It seems like a little intimidating if you don't have a background. And I was wondering if you could kind of speak to your experience about learning something with your students and how that's maybe helped or how you've maintained that, maybe level of professionalism as you trip and stumble.
Yeah, so that's a big question. There's so much to say there. I guess, sure. I mean, I think that you see my background. I'm not a statistician, but I think that I've learned alongside my students a lot through a couple of different ways. I mean, I've taken my own online classes. I've worked with DataClassroom. In the 12 years that I've been teaching science research, when I started teaching first, I think the program used SPSS, and then we moved to Excel, and then we finally found DataClassroom, I think about 5 years ago. So we've been using DataClassroom for a while now. And by far, DataClassroom is the most supportive, and the explanations make sense. So I think that if there was a chart that I showed where you can see all of the types of statistics the DataClassroom can do. And every once in a while, I'll have a student that does something outside of that or beyond. Not often at all, but that's when I really have to dig into, like, why doesn't this apply? Or sometimes there are subtleties in the data. The data is not a continuous variable. It's a different kind of variable, and so we really have to stop and think whether certain statistics apply. And so we really just do our own research on those, and we ask mentors and we ask Aaron. Aaron has gotten some emails from me. So that's how I approach it. So it's more of, I dig in alongside the student to figure it out.
Awesome. Okay, that's great. And I think it's really powerful also when like educators and mentors do that in front of their students. I think it's a good modeling of that. Okay, Anna, you are up. We've had a lot of interest in your research. I think I'm also just going to highlight that in your pathway, I think I saw that you have never taken like a formal statistics course, correct? Yeah, so very impressive. I think like when I was looking at your graphs, I think it's really helpful, right? Or you have like all these like data points that may not actually show a story right away necessarily. And then with a tool like DataClassroom, it's really like easy and implicit like to use. When you throw up a box and whisker plot, the story became really clear, right? A lot of data points that might not have looked like they should really any difference. Clearly there was a difference. So a few things on your research. How did you go about collecting the data from that number of respondents? Like, did you have a goal for how many you were aiming for, or just trying to get as much as possible? And then what were your variables and what procedure did you choose in getting your sample?
Hi, thank you so much. Yes, you were right about the I never took a formal statistics class, and about that question, I can see Miss Zielinski was smiling because she actually said that 100 was the goal, but once I got to about 50, and that was around what other behavior students were collecting. She was saying, "Okay, you're doing good," and I said, "No, no, I definitely want to get the 100." So me getting 101 participants is definitely no coincidence. That was very intentional. And I also wanted to, I wanted to make sure that my data, one, that it was more likely that I might have a statistically significant result if I had a larger sample size, and I wanted to be able to have any statements that I made in the application of my research be more accurate. So I figured if I'm in a school that has about 1,000 people, if I survey 1/10 of my participants, that would be a representative sample. And then, sorry, for the procedure for collecting data, I looked a lot at the demographics of Sleepy Hollow as a town and the high school because I wanted to make sure that the demographics of my sample were as close to the population as possible. So I mostly collected through classes because I didn't want it to be a voluntary participation. I wanted it to be as representative as possible. Sorry, I'm just reading the rest of the question. Um, yes, did I answer everything? Okay.
Yeah, I think that was great.
Yes, that's great. It's a nice. I teach AP statistics, and I was a math teacher before becoming a computer science teacher. And without a background of AP statistics and or anything, she is very confident about the data on sample. I just want to ask. I know I don't want to test her, but she did a wonderful presentation. Good job.
Thank you. Yeah, she did. I really feel like she knocked it out of the park. I guess one thing that I just kind of wrap up, I want to be cautious of everyone's time is, the right tool and something that you can bring in your classroom. Michelle mentioned SPSS. I've also had to use SPSS even at the undergraduate level to teach statistics. There's just things that are a little bit better, not to knock IBM, but better in terms of like helping students learn through data. So I think like what we can all see here is that Anna has never taken a formal statistics course, yet she is a published researcher backed by the statistical tests in a way that like she worked with data and that data allowed her to learn some real complicated and advanced math and statistical concepts. And I think that's kind of the message that I want to leave everyone with, is that it's okay if you don't have a data science background or a statistics background. There are tools out there like DataClassroom that can really help not only onboard you as an educator, but really get your students engaged in learning through something that's socially relevant, engaging for them, and really matters. So I guess I'm just going to say thank you so much, Erin, Anna, Michelle, for your time tonight. If you are an educator and you want to learn more about DataClassroom and other professional development opportunities and tools, we are hosting a webinar next month on April 8th, same exact time. Erin will be there again, highlighting what DataClassroom has to offer in terms of professional development opportunities for teachers that maybe are inspired by seeing the not even the ceiling, since Anna's crashed through that and is now going for another paper, but what students are really capable of doing if we can give them the right tools. So if you want to come to that webinar next month, there is a link in the chat. You can get registered. And besides for that, I want to say thank you so much to our presenters. That was very inspiring for me. Makes me miss being in a classroom and working with students like you, Anna, and have a wonderful evening.